Alright, so this is the second module on OpenFlow. In this module, we talk about only controllers and the OpenFlow tools. 3 items. Controllers and then some software routing platforms. This is nothing to do with the OpenFlow, but it's important to know about them if you are going to do anything in networking. Talk about them and then OpenFlow related tools. For the controllers, there are many controllers, right? So I have put some of the key ones here on this list, and we will talk about them slightly, and this is not a complete list. One of the most common controllers is Knox. Knox is actually not only the most common, but also one of the most first ones. And so when the first Knox came out, people took the code and then changed it their own way, whatever they wanted to do. So most of the other controllers, actually, so this is the grandfather of all the controllers. And so it was developed by Nicira and donated to the research community in 2008, and it's supported by ON Lab. ON is Open Networking Lab at Stanford University and UC Berkeley by ICSI. So basically, these are the two universities which are working on OpenFlow more than other universities. And so actually they are also the one where it was generated, the OpenFlow idea came from. So their lab is ON Lab. Now the main difference between different controllers that we are going to see today is the language, what they are implemented in. That is the main, all of them perform very similar function, which is to speak the OpenFlow. So this one is written in C++ and provides C++ API. And this is both a controller and a framework for developing applications. So if you're developing an OpenFlow application, and we will see some applications at the end, you just use this open Knox code and add your own thing, and then you have the application. Includes sample components for topology discovery, learning switch, and network wide switch. So let's understand those 3 words. Topology discovery means what? Exactly, how the network is connected, how the physical components are connected. So then learning switch. What is a learning switch? Never heard of it. So the normal standard Ethernet switch is a learning switch. Why? Because it learns the addresses by source learning, right? It looks at the source addresses and figures out where to send the packets. So that is called a learning switch. Network wide switch. Have you heard of network wide switch? We have gone through all of this before. That's why I'm asking you. Network wide switch. Anybody remembers VSS? Or there were other names for it too. And distributed virtual switch, DVS. So that is basically, you could just combine all the V switches into one switch, one big switch. That is called network wide switch. Now, Knox is basically now gone. While this is the most common one and first one, but the same guys who are working on Knox, they are working on POX. So POX is basically Python-based newer version of Knox. And it does almost the same thing. It is a platform for rapid development of network control software and so on and so forth. It's a framework for switches, debugging, virtualization, etc., etc. And it has path selection, topology discovery, things very similar to the previous one. Has the same GUI and visualization tools as Knox. It runs on Linux, Macs, Windows, and can be bundled with a install-free PyPy runtime for easy deployment. Okay, so Python, whatever Python runtime is, that one. Okay. So basically, Knox is C++ based, POX is Python based. That's the summary to remember. And if you go today to download POX rather than Knox, because there are lots of features that may not be there in Knox anymore. SNAC. This is simply a GUI for Knox. So if you wanted to play with Knox, this provides you a web GUI, right? So basically, you can you can go to the web page created by Snack, and then you can do management or whatever you want to do. Rather than speaking C, you can do with this better interface. So allows programming Knox routing module policies without editing the code. Allows admission control, shows network components, network usage, and events, etc. So you can also monitor the network and see the results in a graphical form. Reports many flow level traffic details using REST API. What is a REST API? I think we talked about REST API before. Anybody remember? REST. R-E-S-T. Yeah. Did we talk about that? So REST is HTTP-like, basically, because this is HTTP anyway, so this one is no surprise. So basically, you could say get or put or whatever it is, commands and to Snack, and it will give you that particular whatever data you are asking for. New hosts joining the networks are automatically directed to Snack for authentication. So this also has authentication in it. So anyway, so now we have three, and the key thing to remember is Knox is the big first one, Fox is the Python based, Snack is the web based API. That's all. Beacon. Beacon is in Java. By the way, all of these are open source. So you can download the code for any of these and play with them if you wanted to. And so this was developed at Stanford University. And because of Java, it runs on many platforms, including on your phones and multi-core Linux servers. Anywhere where Java will run, this controller will run. And so the code is dynamic. So the code is bundled. Beacon can be started, stopped, installed. So it is basically modular. You can change the modules. Dynamic means you can change it. And uses Eclipse IDE, the development environment. Some of you might have used Eclipse with Java. So that's all there is to know about this. I mean, if you when you need to use it, you can go ahead, download the documentation along with the code, and you will know more about it. But right now, it's sufficient to know that this is Java. And then Onyx. Onyx was not on the list, but basically Onyx is more of a framework. And what they did was the same guys who were developing Knox, Pox, and everything else, they have this framework which says that if we want to do multiple copies of the same controller for availability, for reliability, how do we synchronize them? How do we do this thing? So that is called Onyx. Onyx is basically the framework for distributed controller platform using a cluster of servers. So you have server 1, server 2, server n. They're all doing the same thing. And they might even be doing different switches, but they have to synchronize. So there is a synchronization protocol that these guys have talked about. Okay. So that is Onyx. Onyx is basically a distributed, basically how do you distribute a controller? Okay. And obviously the what is synchronized is not really the state, but the database. So there is a database here, which is, this is the database, network information based NIB. That is the database, and that is synchronized by this sync thing that they have developed. So Onyx is really not a controller, but it's a framework for distribution. Then there is a controller called Prema. This is developed by NEC Research Lab in Japan, and it is developed in Ruby. Again, the features are not very different. It's they have just mostly the language is different, and then some feature obviously might be different, but this is modular and extensible and so on and so forth. Maestro. Maestro is another one which is Java based, developed by Rice University and supported by NSF. The key thing about Maestro is that it allows parallelism by having multiple threads going in parallel. Okay, so this probably has a better performance. So a controller is not a bottleneck. All right, so two things to know about Maestro is Java based and multi-threaded. That's it. not a big deal. Floodlight. Now this is the last one. Floodlight is a commercial, actually was commercial, actually is, let me not say commercial, but this is commercial grade. This is open source too. It's a commercial grade developed by Big Switch Network. Okay, Big Switch Network is one of the two companies that started from Stanford. One was Nicera, second was Big Switch Network. So Big Switch Network developed this controller, and it is based upon Beacon. And you saw Beacon is in Java, so Floodlight is in Java, and it runs on a Java virtual machine. And it uses Indigo. Now, we talked about Indigo. You probably forgot about it when we talked about the switches. Indigo is the firmware that you can use, actually we call it software, to make hardware switches do OpenFlow. So it can talk to Indigo. Indigo is basically how you change a hardware switch to OpenFlow switch by using the Indigo software. So the Floodlight is the core of the Big Switch controller. So now Big Switch Network sells Big Switch controller. So they have their own controller, which is actually, we can call it a commercial controller. But they use the main part of their controller is this Floodlight. All right. Here is the symbol for Floodlight. Now, so everything else is as standard. Basically, you have the apps, you have the controller, you have the Indigo data plane, it says here. So, if you have Indigo, you have the switches which use Indigo, you can use that, but you can also have Open vSwitch. Everybody supports Open vSwitch. All the controllers that we have talked about, although I may not have said explicitly, everybody supports Open vSwitch, which is a software switch. Floodlight. All right. Now, Floodlight has few more things. Neutron plugin. So first of all, what is OpenStack? For cloud computing. So if you want to play with cloud computing, you download OpenStack, and that is the platform that actually not all, many of the cloud service providers use. Okay, so they use OpenStack. Now OpenStack has many plugins, many things you can do. One of the plugins is called Neutron. Neutron is the one that does the networking part of it. Right? So if you want to create networks, links, this and that, whatever, you use Neutron. So this Floodlight has a Neutron plugin. So you can put in the OpenStack that plugin, and now it can talk to your controller, and you can control all the switches, you can program them and all that, right? It has many applications which have been developed, such as a static flow pusher, allows user to manually insert the flows. Circuit pusher creates permanent entries on all the switches along the path. You can set up a circuit. Firewall, you can put the control list on the switches and saying that only these flows can go through. Big virtual switch, and which is that basically a large, if you have a large network, then you can provision the data centers. So this is very much like that plugin that we talked about. All right, so these are the most important controllers. Now this is only a partial list. There are many other controllers, as I said, but most of these are gone because we will talk about a controller in the next module, which is the future. Okay, all right.